Assalamualaikum students, welcome to another video of study with ARS. Today's our topic is vanderwaal forces. Okay, so this is the property or in molecules only. Okay, this is the property in molecules. Okay, so vanderwaal forces means it is the attraction between molecules to molecule. Attraction between molecules to molecule is called molecules to molecule is called van der Waals forces. Okay, so basically there are three types of van der Waals force: one, two, and the third one. Okay, so the first one is with the name of dipole interaction, or you may call it as a bond or attraction. Dipole bond, dipole attraction, anything else. And here we have got hydrogen bond, hydrogen on the second, and the third one is London dispersion force. Okay, so now let's look at first in dipole interaction bond. So it is the property in which it forms a physical bond. First of all these forces are having physical bond. Okay, physical bond. But to specify the dipole bond, we will be using that it is having physical bond, but only between less electronegative molecules. Okay, it is having a means physical bond between less electronegative molecules. Let's look at the example. First of all, let's look at the what are less electronegative, like carbon, bromine, and other are also there. Carbon, there are others as well. I think carbon, bromine, and I'm not getting the names now. Okay, so now till now only these are here. Okay, so let's look at the example of HBr and iodine as well. There are other as well, iodine and sulfur. There are a lot. Okay, so let's look at the example of Hi. Okay, so for example they are in a bond. Okay, and there's other one bond or molecule of Hi, and it is iodine gas. Till now it is hydroiodine gas. It is not hydroiodic acid. It is hydro iodic iodine gas. Hydroiodine gas. Okay, so now as you know that iodine is having a bit more electronegativity than the hydrogen, 3 point something, 3 point, I think 2.8, yeah, 2.8, and hydrogen is having 2.1, so 0.7 is the difference. Okay, so iodine will try to snatch the electron of hydrogen and will be getting a minus partial sign, and hydrogen will be getting a partial positive. Here the same method will be taking place, and so now this is having a partial negative, this one iodine, and this one hydrogen is having a partial positive. So as you know that between positive and negative charge there is a attraction, so there will be a attraction, and that attraction will be between the less electronegative molecules and will be called as dipole attraction. Dipole dipole attraction. Okay, so this attraction between the less electro negative molecules and the means the now the product will be in liquid. First of all, it was in gas, and the name will be of this liquid will be hydrogen no hydroiodic acid. Now it will become a liquid, and the name of that liquid is hydroiodic acid. And first of all, it was in gas, so the name of this one was hydrogen iodine gas. Okay, hydrogen iodine gas, and will convert into hydroiodic acid, which is a liquid. Okay, so now let's look at the hydrogen bond. So hydrogen bond is having a physical bond between greater electronegative electronegative elements. Okay, so like uh, we'll, first of all, let's look at what are high electronegative. So chlorine, fluorine, and there are others as well. Okay, nitrogen, oxygen, and other as well. Okay, so let's look at the example of hydrogen bond. For example, here we are having uh, HCl. Okay, this is the one bond of one molecule of HCl here, and the other one is here. So the same method will be happening here. Chlorine is having a more electronegativity and will try to snatch the electron, will be getting a partial negative. Hydrogen will be getting a partial positive. Here also the same process will be taking place, and now the attraction will be forming like here. This one attraction was there, so this attraction will be known as attraction, and that attraction will be known as hydrogen bond. Attraction will be known as hydrogen bond. Okay, so this will also form a liquid. But I should need to tell you one thing here, that these vanderwaal forces have will in a product they will be giving liquid every time. Okay, because it is between the molecules of gaseous elements. So when the gaseous element will pressurizing together, so they will be forming liquid. They can form solid as well. Okay, so when they will be pressurizing, then they will be forming liquid first. Okay, so now let's look at the London dispersion force. It is between heteromolecules mean different molecules. It is also between heteromolecule, and this one is between homomolecule. Homomolecules means same atoms combined together and will form a molecule, is called homomolecule. Okay, so now let's look at the London dispersion. So it is a physical bond between molecule to molecule, and the molecule should be same here. Okay, so physical bond between molecule and molecule will be same here, with the same electronegatives, the same everything. Okay, so they will be same. Like we are having an example, there will be let's look at the example of H2. Okay, and here is also H2. So first of all, the means here is H2, and it is having 4 electron here, 1 2 3 4, and has another H2. Okay, it is having four electrons here. One, two, three, four. First thing I should need to clear one thing, that why these electrons are on the this side, means on the A side. This one is the P side. Why these electrons are on the A side is cause is this, that there is some particular time where the electron, all the electron moves on from this side to this side, and there are some millisecond in where the electrons of hydrogen move towards the A side in milliseconds, and in milliseconds the electrons of hydrogen move toward this side, and here will be positive sign. So four electrons, so four positive sign will be here, and here will be four electrons. Why there will be four electrons? The reason is this, that there is positive sign will be attracting the electron of this one hydrogen, B hydrogen, A hydrogen. Okay, the electrons of the protons of A hydrogen will be attracting the electron of B hydrogen. So there will be a formation of bond, formation of physical bond. Okay, so this bond is called London dispersion bond. So hope you guys have enjoyed our lecture. We'll see you in the very next video.